Hello everyone, this is Sachin again, and today's session I want to talk about a tool called BrainBoard. So, um, um, so usually when we want to deploy our component into cloud, we can manually do that. But the problem with manual is like it is a tedious process, and then you have to clean up your component, and sometimes you want to repeat it. It is not repeatable. You have to go through the whole pain and time spending. So to save that, Terraform scripts helps us, and I have been doing all my POCs and real-time projects using Terraform scripts. But still, there is a one problem with the Terraform, though it solves your, um, you know, um, repeatably deploying components into cloud, and once you don't need them, you destroy them, so you save on your cost. However, it is very hard to basically evolving on the place where you were, which means let's say I have set up a basic architecture, and tomorrow I just want to build up a new one based on that, and let's say I have a few more components. It's very hard to visualize. So that's where, this tool, I find it very fantastic to basically, it's just a matter of drag and drop, and your whole architecture diagram is right in front of you, and the Terraform scripts are created. I'll just quickly show that in a moment. But just to let you know, this video is not a sponsored. BrainBoard doesn't pay me anything, but one of my colleague, Mr. Prabhu, thanks to him that he told me about this tool, and I found it so good that I want to cover it in my session today. All right, so let's get started. So once you go and register for your BrainBoard account, you get a 21-day trial. For me, I did it like I think day before yesterday, so 19 days still left. All right, so once you're here, you choose your provider. I have chosen already AWS, and whatever component you want to build. So typically, I want to cover just for demonstration purpose is you should have an VPC and two subnets, one public and one private, and deploy EC2 instance, one in each subnets. And because they are public and private subnets, you have to come up with the internet gateway associated with the route tables and with the public subnets. And private subnet, my requirement is that it should, the EC2 instance which we deploy over that, it should be communicating to the outside world. So which means there is a NAT instance or NAT gateway is also needed, which should be there present in public subnet. So let's see how it works and how easy it is. Like typically, it takes a couple of hours to days to basically just do everything from scratch using writing Terraform. However, here it's a matter of drag and drop, and I think pretty much you can do everything within half an hour, even if you're like the first time you're doing this. So okay, just so VPC. And once you hover your mouse, let's say virtual private cloud, you see on the right side VPC virtual private cloud is small Terraform type AWS VPC. So if you are doing a Terraform coding, you can relate, okay, this is the right VPC component or any other component which you are dragging and dropping. So try, just take it, drag on the right side. Okay, there you can adjust it, and there are some properties which you can change it, the resource name and the region, and some advanced configuration depending on this particular component VPC. And there is a small text box over here which is like for your reference, if you want to give it some meaningful name. So which, just to let you know that you can actually modify that. So I'm just saying it my VPC and click on the save button. So that's where you come to my VPC. Now let's quickly drop the other components which we need, like subnet. Okay, again under virtual private cloud you find VPC subnet, and on the right side you see small Terraform type AWS subnet. So that's how I know, okay, this is the right component. Take it and drag it on the right side. All right, now this just says subnet by default, but I want this to be a public subnet, so I would like to rename it to public subnet. All right, Sims VPC subnet and drop it on the right side. And this time I want to call it a private subnet. So I can again double click and say it's a private subnet. And later I can you can drag and drop your EC2 instances over here. Just click add, and one more EC2 instance on the private subnet. All right, so I'm not gonna do everything over here right in this demo, but I hope that you'll get an idea that you can actually design your components over here. And when you see a right small arrow, if you just click on it, you see at the right side the Terraform scripts are auto-generated. There are like all these files you can navigate and um, look at the content of that. But for now, whatever component I have dropped, they are the Terraform scripts I've created. They're not editable. You cannot edit the Terraform scripts directly. All you need to do is like design your components on the left side, and this will be auto-generated. All right, so I hope you get an idea. So I just go and click what I've already designed before recording this video. So this is the typical architecture we want to cover up, where we have a VPC, we have a public subnet and a private subnet. There is an input and output for variables. You click on this input and basically you can define all your inputs, which I have defined, like what kind of an instance I need, what is the key pair name. In my case, it is such an AWS KP3. Yours will be different. And a couple of other variables like what is my CIDRs, what is my VPC CIDR, and so on and so forth. That's pretty much. So once you define your input variable and you adjust all that settings over here, so not only just naming it, but you can go to settings of any component. Like I have gone to public subnet, and you can also see Terraform type over here. You can basically put what region it is, and that I'm getting from variables, so I just var.aws region, and so on and so forth. All right, so just to let you know, few other properties, though the intent is not to basically cover this BrainBoard in depth. You can go there and like things are very intuitive, but just to give you a small idea that you can design your component and deploy it in your cloud. So for example, like EC2 public, you can actually click on the search attributes as well and say it's associate. Yeah, so something like I want my EC2 public instance to have a public IP. That's why I say associate public IP address to be true. I just want to show that you can search and view or change some parameters which you are looking for. But if I go to my EC2 private instance and I do not want the public IP to be assigned over here, and that's where like I left it the default, like don't associate any public IP address with this. Anyways, so now once my design is over, and you can see it's a VPC, two public and private subnets, and EC2 instance, one in each. I have added my NAT subnet and an internet gateway associated with the VPC. The security groups, for now security groups, I have allowed everything. For my demo it works, but for a production environment, just allow those ports what are required. And for that instance to work, an elastic IP is needed. So you just drag and drop an elastic IP and associate with the NAT instance. So I just show you that how this arrow marking or associations work, just with an example over here. You go to the setting and advanced configuration, and you can say allocation ID is AWS EIP, which is a name for this component in Terraform, and whatever name you have given .id. Anyways, so once your design is over, you click this small arrow and you can see that all your Terraform script for main.tf is generated over here, and there are other files also getting created. Now only thing you need to do is like to deploy it into AWS cloud. So for now, if I go to my AWS cloud and if I see my running instance, let me refresh. Okay, there's nothing over here. There's no EC2 instance running. If I go to my VPC and if I check my VPCs, there's only default one, so there is nothing other than that. So pretty much this account is cleaned. Now what I'm gonna do here is either you can go here on the right top corner and say cloud provider, you choose your AWS and add your access key and secret key, and you can deploy directly from the UI. Or what I'm gonna do and show here is basically you can download all the files and manually issue this command if you're comfortable with. So let's go to the command prompt, and this is my download directory, and there is absolutely nothing over here. All I'm going to do is download all files. All right, so once you click this, this will download all the files in a zip file with name something like BrainBoard or whatever your project name is. In my case, it's 01 Basic. So this will be downloaded, and you can unzip it, and that's where everything will be visible over here. All right, then all you need to do is Terraform init, which will initialize the project based on provider and the Terraform versions and all that stuff. Oh, give it a couple of seconds. Okay, so Terraform init is done. Now you just say Terraform plan. All right, so there I see it is going to add 13 components, 0 change and 0 destroy. And now I'm going to do is Terraform apply. I know what I'm going to do here, so I will just say auto approve. Perfect. So now we see that this has started going to create these VPCs, elastic IP, and all that stuff. And meanwhile, it is creating, let's go to my AWS account and refresh this. So now I see my VPC is getting created, and this is getting the same CIDR, which is in my input variables. So force looks good. Internet gateway, and I see my IGW is also getting created. There should be NAT gateway also with a similar name. My NAT, okay, it is still pending, it is in process. So, and this is also going to create AWS instances. Let's quickly see them as well. So I went to EC2, running instance, closes, there will be in pending state. Okay, so one public and one private instance is getting created. So all I'm going to do here is actually pause this video for a couple of minutes because it will take some time to deploy and basically make all these connections and keep the things ready. So let's wait a couple of seconds. All right, so I just waited, I think another 30 or 40 seconds, and everything was getting created. So, and that's where I see the message apply complete, and all these 13 resources are added. So let's go here and refresh it once again, and we see that still this is in running state, but the status check is initialized. Let's verify the other components as well. So yes, there was an EIP over here. Let's quickly check that. EC2, and there should be an elastic IP somewhere down. Elastic, okay. Elastic IPs, perfect. So this elastic IP is created. Associated instance ID, there should be a NAT here. NAT gateways, perfect. So NAT is also created. All right, so far it looks good. Now all I'm going to do here is, if I see EC2 public, and I see there is a public IP associated with that, and there's a public IPv4 DNS, this long name. But if I go to my private instance, and if you remember that I have not checked that option to assign a public IP, so there is no public IP for this, no public DNS for that, and because it is not, this subnet is not associated with the internet gateway, there is no direct public connectivity. So quickly verify the route tables associated with each of them real quick. So I'm into my EC2 public, and what makes this public is basically this subnet. If I say subnet, this ends with 9D, click on that, and this subnet, if I see my route table, this is RTIGW, stands for Internet Gateway, and if I see the route, the default route goes to my Internet Gateway. But if I close this window and I go to my private instance, and again I follow my private subnets and with 0E, and if we see the route table, it is RT NAT, and in fact here itself we can see that the default routing is to the NAT gateway. So far it looks good. I think status check is also green for both of the box, so now all is needed to basically validate that I can SSH to this machine, and from this machine I can go to another machine. So I'm copying the public IP address and SSH this guy. Okay. So I don't have to give it credentials because I have baked my image in such a way that in the known host or the authorization host, I have put already my public key, and that's why you don't see I am not providing any authentication over here. and it directly authenticate because it knows my Mac system. Anyways, so I see I can be in the public EC2 instance 12.1.0.2.1.3, 12.1.0.2.1.3, and from here I can SSH to my private instance, which IP is 12.1.1.45. Before that, I just need to adjust with my SSH key permissions. So let me fix that. chmod 400.ssh/idrsa. Now I can go to this particular box and voila, it lets me in 12.1.1.45. Now I'm into this box. So basically you can see I SSHed in this public instance, and from this instance I was able to SSH to this particular box. And last thing we need to check, because we associated an NAT gateway, place it into a public subnet, and with this subnet, routing has been done this way. So ideally we should have a public connectivity in this box. All we need to do is ping noodle.com and it works. All right, so I hope you enjoyed this video, learned something new. If that's the case and you want me to create such contents, please like this video and share it with your friends. Thank you. For any doubts, please put into comments. I usually try to reply in time. Thank you.